Hello, dear students. Now we are talking today, or this moment, about disagreement in the second area, self-explanatory first principles. Remember we talked about the first principles of the three types, self-evident, self-explanatory, and borrowed. And we showed that in borrowed first principles, there wasn't disagreement, okay, between John and Isaiah and Peter and Paul and all that. Okay, we are going to find disagreement in self-explanatory first principles. There's disagreement between Einstein and Newton, but it's only disagreement over time. Okay, if Newton were alive today, Newton and Einstein were alive today, talking with the masters of quantum physics, they'd say, "Cool, man! I didn't know that. That's really cool." Okay, but when Einstein first came about and everybody was following Newton, they said, "Well, wait, is what you're saying true? We gotta test this, okay?" And then once they tested it and found out, remember in self-explanatory first principles, you understand the words of the first principle, but you don't see that it's necessarily so. You understand what it means, but you don't see that's necessarily so. You judge the veracity of this guess, the truth of this guess, by the results you get. If you get rockets to the moon, if you can bend, you show that the light wave bends or something like that, then you say, okay, it must be true, the first principle, because everything you predict happens. And that's what happened with Einstein. Einstein came about, and he came out with his work on the special theory of relativity and the general theory of relativity. And remember we talked about light moving always at super fast. And it doesn't matter whether you're moving super fast as well or you're stationary, that light is always going to, with respect to you, always going to have the same speed. So here's Johnny staying still, here's Joey moving really fast, here's the same light wave. It's the same speed with respect to Johnny as it is with respect to whoever this guy's name was, Joey. And you say, I understand what you mean by that, but how is it so? Well, let's experiment. And the guys were maybe, I'm joking, I don't know what happened, but the Newton guys went and said, "That's dumb, we're not doing that, how stupid. We're getting rockets to the moon with," I don't know if they got rockets to the moon at that time, but anyway. "And you want us to believe that? Well, let's experiment." And she said, "Oh my goodness, look at all these things that you can do with this that we couldn't do with Newton. Man, you must have really come on to something." And then more experiment. "Okay, yeah. Thanks, Newton, we still love you. You really contributed to this, okay? But now we've advanced." That's the way they might say it. "We've advanced our first principles, okay? So that you had a part of the truth, say, but now we're more clear, not part of it, but more clarity on the way things work in nature, the physical laws of nature, okay? So in general, let me see, look at my notes here, see if I have anything else I want to say. Yeah, so let's just say, with respect to, let's take the principle of Newton. Remember how things are attracted to each other, gravity, and a thing will fall at the inverse square of the distance, and we talked about that, and then, okay, that works, that's cool. And then remember how Einstein said, well, like we talked about, a ray of light moving with respect to the guy in still or guy moving fast, it moves at the same relative speed. You say, well, those are, here they're moving at a mathematical, depending on the mass, and being calculated out. And here it's moving in one speed with respect to one person, one speed with respect to the other. Well, those don't agree with each other. And you say, okay, well, which first principle do you want to take? And again, you just experiment, and see. And especially once you develop ways in which you can experience nature more with whatever telescopes, with other micro light, whatever, you say, oh, look, we didn't have the ability to experiment this way before, now we do. And you say, you know what? Einstein explains a lot more, predicts a lot more than Newton. Therefore, we're going to put Newton, we're going to read Newton and study him and everything, and that's cool, but we're going to call ourselves Einsteinians or all of that. And I'm not sure, but I think he would say, with Einstein, we talked about waves and light being waves and light being a particle. And then with the quantum theory of physics, you say, well, it's both, and then the things at two places at once. And you say, well, that's really cool. I don't know quantum theory at all. But the way science is going now, those are, now it's maybe string theory or something like that, but those first principles are held more than Einstein, which are held more than Newton, which were held, say, more than Ptolemy, but that's more of art, that's more of astronomy. Okay, so in self-explanatory first principles, there is disagreement only historically. But once, if those things are together, it only takes experiment to say, okay, let's put that on the shelf and let's adopt these new self-explanatory principles. Okay? Thank you so much. Bye.